Welcome back, physics fans, and here we go with number 10 from Static Equilibrium, Physics 12. A 15 kilogram uniform beam that is 2.4 meters long is suspended from a wall and a ceiling as shown. So there's a hinge here. It's 0.8 to where it's connected at a right angle to a supporting wire. And then the rest of it, 1.6, because 0.8 and 1.6 goes to that 2.4. Goes all the way down to the end where there's a mass of 25 kilograms at the hanging on the end of the beam, and the angle here is 65 degrees. So to help assist that, I've sketched out a free body diagram. I'm just going to quickly label them, and that is the, whoa, that's an awfully big felt, and that's not what I wanted to do either. I wanted to draw red, really small one, F hinge. Okay, you might not know what direction that is, but I already put it down there. This will be of the support wire. So that's a wire, so maybe there's a tension of the wire. And this is the force of the center of gravity, which is in the middle of the object. It doesn't actually look like I've drawn it in the middle, but that doesn't matter too much here. And this is the force of the mass. Force of gravity of the mass, force of gravity of the mass. Okay, free body diagram's complete. We'll leave it like that. We'll just copy all that stuff over here and get some angles in here. We know this is 90 degrees, so I'm not going to ruin my free body diagram here. We got the tension of the wire, and this distance here is 0.8. This distance, which was to the center of gravity, will be 1.2 meters because that is a uniform beam. Uniform meaning its mass is evenly distributed, so that'll be 1.2 meters. And with the wall, with this wall and the force of gravity down, this will also be 65 degrees. And this will also be 65. But if you want to take the complement of it, the supplement of it, and do the 115 degrees, you could use that as well, because the torque formula is force times distance times the sine of the angle between the force and the distance vectors. There's the distance vector, and there's the force vector, and you can use either one of these angles because the sine of them are identical. Sine of 65 or sine of 115 is the same. So we can use whatever we want. You might feel more comfortable doing 115. Whoops, I'm drawing them on the wrong one. You don't label angles in your free body diagram. So 115 and 115 degrees. Okay, and that's the FG of the mass and F center of gravity. So we have the angles, we have the distances, and the forces, so we're ready to go. So what is the tension in the supporting wire? So we're going to put the pivot point at the hinge. And this is a good explanation here, is because we don't know anything about that angle. We don't know anything about that force. So we don't have anything on that force. So we put the pivot point there. So the torque disappears. We still have to draw it in the free body diagram, but the torque caused by that force, the force of the hinge, disappears. So when I start doing the sum of the torques, have to equal 0 when the pivot point is at the hinge. Then I don't have to put any torques by the hinge in there because there are 0. Okay, so now let's just start racing through it. Here we go. The torques counterclockwise is equal to the torques clockwise. If this is a pivot point, you stick a pin in it, and then this force is going to make it rotate around that direction, and that's the counterclockwise one. So the torque of the wire will equal the torque of the other ones that go the other direction, which will be the torque of the center of gravity plus the torque of the force of gravity of mass. So those are the torques that we're dealing with. Someone asked me, how do I know if it's counterclockwise or clockwise? And sometimes people might not know the distinction between those, but you need to understand more so than which, if it's counterclockwise or clockwise, is it turning it this way or are they turning it that way? As long as you put these two together, these two torques together, opposed to the other one, then that's what it still works. If you get the clockwise and counterclockwise mixed up, you'll still get the proper answer. Maybe you were just doing a digital clock instead of an analog. Okay, so we'll continue on. The torque of the wire is, using this formula, FD sine theta, is T, the distance, which will be 0.8, and times the sine of the angle. And the angle is actually 90 degrees, and the sine of 90 is just going to be 1. This is going to be the force of the center of gravity times its distance times its sine of the angle plus the force of gravity of the mass times its distance and its angle. So at this point, I'm going to start putting in numbers, change it over to black. T is what we're trying to solve for. The D is 0.8 meters, and that's all that's on the left, because there's a 1 for the sine. F cog, now it is a 15 kilogram beam. The force of gravity of that is mg, which is 15 times 9.8, which is 147 newtons. And this guy has a force of gravity of mg, which is 25 times 9.8. And that equals how much? 245? So F cog is 147 newtons at a distance of 1.2 meters, halfway along, and it's also the sine of 115. Or 65, both are accurate, both will be perfect. Fg of the mass is 245, and its distance is at 2.4 meters away from the pivot point. And since we put the pivot point at the other end of the beam, it's the length of the beam. And it's also the sine of 115. So at this point, we just start doing some math here. And at that point, you've got at least a high B, because now it's just the math. 1.2 times the sine of 115. And I could get that number there, so you might want some numbers in between. Might. This equals 159.87 Newton meters. And this is 245 times 2.4 times the sine of 115. And that is definitely a lot larger, 32 532.91. We'll add those together, and we get the total torque in the clockwise direction is equal to 692 Newton meters, 0.78. And that's the clockwise torque as well then. And if the clockwise torque is 692.78 and it's pulled at a 90-degree angle at 0.8, then its tension force is, so divide that by 0.8, and it's 865. let's just do 866. Excellent. Subscribe, smash that like button, leave those comments, share it with lots of people. Watch it a few more times. Thank you.